All right, when you're solving systems of equations, no matter what method you use or what size the system is, there's always three possible outcomes. The first, most common one, is that you have one solution. Other words for that are consistent and independent. So one solution, also known as consistent and independent, that's the most common of the outcomes for most algebra classes. Second possibility is that there's infinitely many solutions. So if you're dealing with a two-variable system, that means there's an infinite number of ordered pairs that are the solution to that system of equation. And that's called consistent, bless you, and dependent. Yes, you do need to know those words that go with those. So if it's got answers, it's consistent. If it only has one answer, it's independent. If it has infinitely many, it's dependent. So consistent means it's got answers, and then the independence is only one answer, and then the dependent is that it's got tons of answers, infinite number. That third possibility is that there's no solution. If consistent means it has answers, no solution or no answers would be inconsistent. Very logical way of putting it. So just inconsistent there. Okay. There's several ways to solve systems of equations. In Algebra 1, you talk about substitution and elimination as methods for solving systems of equations. Get to Algebra 2, you do that again, and then we start going into the things with using a matrix to solve a system of equations, which is by far and away the easiest way of doing that because it doesn't require a ton of work on your part. So it's definitely the easiest way, and it also takes the variables out of the way, makes it much easier, a lot less arithmetic possibility of arithmetic mistakes and things like that. So that's the method we're going to employ in these first couple of sections. Is we're going to solve systems of equations. We're going to use the matrix operations to do that. So we're going to solve example A. Just to a two variable system here to start with. All right, so two variable system, both linear equations there. We will actually do nonlinear systems in here, which we can't do with matrix, but we'll take advantage of it while we can when we can use that. So it's linear because you could rewrite those in slope-intercept form. There's no exponent on any of the variables. That's what makes it a linear system. And if you think about Algebra 1 style, you could multiply the top one by -6 and get the y's to eliminate. Use elimination to solve it. You could solve this first one for y. Y equals -2x plus 5, and plug that in here and solve the equation for x and get your solutions that way. But we're going to do a matrix. 2, 1, 5, -4, 6, -2. What size is that matrix? I remember. 2 by 3. 2 rows by 3 columns. Important to know that size because you got to put this in your calculator. If you don't recognize the size, it's going to mess up on the calculator. Okay, so let me see if I can get my calculator to open now. See what happens here. There we go. All right, so we're going to put a matrix into our calculator. So the matrix menu is under second, and then next inverse. That's one way to get there. If you want to use those F1, F2, and F3s, those actually will work as well, and you might be quicker with that. I don't know. But anyway, the first menu that comes up is the names menu. That's where you select a matrix. It's not where you put one in. You're going to have to go over to edit to put one in. So go over to edit. And my matrix A is a 2x3 already. It really doesn't matter. I'm just going to pick one of those. And then it's automatically going to ask you what size do you want. So if it's not the size you need, you change it right here. So we need a 2x3, so we'll type a 2 there. If there's a number already there, just type over the top of it. It overwrites it for that. So 2x3. And then put in that matrix 2, 1, 5. And then the second row is -4, 6, -2. And make sure, go back before you get out of this window, make sure you got all the signs right. Because if you miss one sign or mistype one number, completely different problem. Kind of like if you mistype, or y'all guys don't type phone numbers anymore, you just hit people's names. But if you were to type someone's phone number in and you missed one number, it'd get a completely different person. They probably don't even know the person you're trying to call. It's crazy. You'd think it'd be close, but it's not. So anyway, so make sure your matrix is in correctly. Input is a big thing. How many times have I seen people get frustrated because they just missed a negative sign somewhere? So if it's a plus or a minus on the problem, if it's a minus, it's a negative. Treat it that way. All right, so I'm going to go back to the main calculator screen. So I'm just regular calculator screen, and then I'm pressing second matrix again. So it's that X inverse button down here on the left. Why this view is.
Students who are going on the HOSA field trip need to report to the front lobby.
Uh-oh. Crash. Matrix. And then this is where you're going to go over and pick which one you're using there. Okay. So we want to do, does anybody remember the command to get it to do this? Say it again, Joel. RREF is the right one, yeah. So alpha B, and then I want to grab that matrix that I put it in, matrix A, and then my OCD makes me close the parentheses. You don't really have to, but I feel like I do. Okay. And you get this reduced row echelon form of a matrix, of a 2x3 matrix. The first row, the one right here, says that's X equals 2. Second row says no X's, but 1Y equals 1. So X equals 2, Y equals 1. That's our ordered pair solution out of that. So through RREF, we get 1, 0, 2, 0, 1, 1. And that equates to the ordered pair 2, 1. Yeah, first row is going to be X, second row is Y, third row, if you've got one, and we get to the 3 variable systems, it's Z, 4 variable systems, just it's alphabetical order is the way the variables will go.
The last ones in your matrix are always
Yes, absolutely. That's correct. Unless there's no solution or infinitely many. Yeah, that is exactly where the line, if you graphed them, where the lines would have crossed. Another way we solved them back in Algebra 1 and Algebra 2 is we graphed them and saw where they crossed. Okay, so much cleaner way of solving here. Let's do this one. 2x plus 3y equals 1. Negative x plus y equals -3. Matrix 2, 3, 1, -1, 1, -3. And then through the magic of a reduced row echelon form and the graphing calculator, I'm going to do the matrix. And I don't know why my buttons are so small. I'm going to try to reopen that, see if it'll get the size of those back to where they're supposed to be. That doesn't make sense. It's still small. No. Oh, that was the wrong move. I don't know why that's looking that way. Oh, well. We'll deal with it. All right, so through RREF, what do we end up with there? It's the ordered pair, so it's 1, 0, 2, 0, 1, -1. So the ordered pair, 2, -1. And that's all I said. That is where these two lines would have crossed. All right. Let's do another 2 by 3. 2x plus y equals 5. 4x minus 8 equals -2y. So this is where we kind of deviate away from the easiness that we always saw in algebra 1 and 2. What's wrong with this system? Yeah, stuff's in the wrong place. So just fix it. Plus 2y plus 8. That gets you 2x plus y equals 5. 4x plus 2y equals 8. And then you put your matrix in there. Got to make sure first column is x's, second column is y's. Get the larger ones. Third column would be z, or whatever, how many letters you've got. Now that. We do RREF with that one. What is the matrix that is left over? So I'm gonna actually do this one. Edit. 2 by 3. 2, 1, 5. And then we have a positive 4. 2, 8. Good thing about using the same matrix call there, you can go back and get that.
Dee Milford, Sarah Wilkerson, Kelsey Franks report to the office.
All right. This one looks a little different. We don't have 1, 0, and then a number, and then 0, 1, and then a number. We got, what's this say, this last row? 0 x's and 0 y's equals 1. Does 0 ever equal 1? No. So the last row there indicates that this has no solutions. That last row is going to tell you that. If it's zeros and then a number, then it's no solution. It is, but the bottom row says, well, this says x plus 1/2 y equals 0. That's what that says. It doesn't say x equals 1/2. It says x plus 1/2 y equals 0. Bottom row says, though, that 0 equals 1, and that's never true. So that bottom row trumps the top, any other row. So this tells us that there's no solution. Good question. We'll do that on the next exam. Does 0 always equal 0? True. So if 0 doesn't equal 1, that tells us no solution. 0 does equal 0. That would be an infinitely meaning situation. Okay. All right. Let's look at that situation, because we're going to go a little bit further than you did in Algebra 1 and Algebra 2 with the infinitely many solutions. All right, so 2x plus y equals 4. Negative 3y minus 6x equals negative 12. So I got to fix it first. First one's in the right order. Second one needs to be negative 6 minus 3y equals negative 12. Remember, first column's x, second column's y, third column's the answers. 2, 1, 4, negative 6, negative 3, negative 12.
That seems very easy.
Well,
You don't have to do anything with that negative 6, negative 3, but move them.
just swap.
You can just move them.
Well, I mean, the negative 6 moves up to the front, and the negative 3 moves to the back.
So that ought to be X, Y.
Mm-hmm. Yeah, technically that's called standard form from Algebra 1. But yeah, put them in a variable alphabetical order is the right way to do that. As long as all of them are in, all the equations are in the same order, and on the right side of the equal sign are just plain numbers, you're okay. As long as all your variables are in the same order, not necessarily.
Both the Y's and X's.
It could be, yeah, and you just have to remember that the first column represents y, not x, which makes it.
Just stick with X.
It's better to just stick with alphabetical order. So through RREF for this, so second matrix, edit 2 by 3, 2, 1, 4. And then negative 6, negative 3, negative 12. All right, got everything in there correctly. And I'm going to run RREF for that matrix. And I get this kind of ugly thing here. 1, 1/2, and then positive 2, and 0, 0, 0. That bottom row, as Holly and Jordan were alluding to, that means infinitely many solutions. But we're not done with this problem. We can't just say it's infinitely many solutions like we did in Algebra 1 and Algebra 2.
So
We'll do something else.
why doesn't it mess it up on the top right there? On the last one, it had a number and a half of a number. So it's a number and a half of Y.
Top row doesn't tell you everything. The bottom row tells you everything. Because it's going to put it in reduced row echelon form. That bottom row is going to tell you if you've got answers or not. If it has zeros and then a number, no solution. All zeros completely infinitely many. Anything with a 1 in that bottom row on the variable side of things, that's going to be answers. The bottom row is going to tell you the tail on all of these. So, all right, so that tells us that this is infinitely many solutions. But we don't stop there in college algebra. We say, okay, let's write them in ordered pair form. Okay, so what we do is we pull this equation right here out. That tells us that it's x plus 1/2 y equals 2. If we write these answers as x, then our ordered pair would be x, and then we would need to solve for y in this problem up here. So I would subtract x, 1/2 y equals negative x plus 2, multiply everybody by 2. So I'd get negative 2x plus 4. That would be my ordered pairs if it asked me to write them in the form of x. That you've got x as itself and then y written as something with an x in it. So the infinite number of solutions work like this. If you picked an x value, if I picked like the x value 4, 4 would be the x, and you could find the y just by knowing an x value. So we're writing how the answers look, what kind of ordered pairs. There's an infinite number of them, but there are certain ones that are part of that infinite
You
group.
have to solve for Y.
Yeah, it depends on what variable it asks for. If it asks for x, we're going to solve it for x, or we're going to write it in terms of x. So that's the only variable you want in your answers. Okay, so if they ask it for as x, that's how it looks. If they ask for it as y, then your ordered pair changes. the y is the plane variable. And then you need to solve this equation to get y being the only variable. So you solve it for x. So x plus 1/2 y equals 2. To solve it for x, subtract 1/2 y. Negative 1/2 y plus 2. That's how they would be in terms of y. In terms of x, x is the only variable in the answers. In terms of y, y is the only variable in the answers. We get to 3 variable systems in just a minute. If it asks for in terms of z, then z is the only variable left in your answers. Okay. So whatever variable they ask it for in terms of, that's the only variable in your answers. You're only going to do that on infinitely many solutions. Because others, no solution, there's nothing, it's not any answers. So there's no way to rewrite them in a different form. One solution, it's just that ordered pair, ordered triple, whatever it is for that problem. So that's the step further we take in college algebra compared to what you probably did in algebra 2 or definitely more than what you did in algebra 1. Okay, so that's the step further. Let's look at x plus y minus z equals -1. 4x minus 3y plus 2z equals 16. 2x minus minus 2y minus 3z equals 5. Listen, I'm tired of this. You need to leave my classroom. You can wake your face up. I'm tired of it. This is every stinking day. If you got to stand up in the back and pay attention, then you stand up in the back. But you're not going to lay your head and disrespect me like that. I work too hard at this place for you to be a little turd and sleep in my class. This is a college freaking class. Wake up! Matrix for that, what size will it be? It is all of these are Z's. It's got a little slash to it, it's a Z. So 3 by 4, 3 rows, X, Y, Z, and numbers, 4 columns. 3 by 4. 1, 1, -1, and then -1 for the 4th column. Yeah. If there's a missing, just like what you remember did long division, there was a missing piece. If there's a missing variable in one of your equations, you have to 0 in that particular column. Remember, first column's X's, second column's Y's, third column's Z's, 4th column. And then you're still just going to run RREF on that. So, second matrix. And I'm going to use matrix B because I already got one that's 3 by 4 size. I usually just keep one that size in there. 1, 1, -1, -1. 4, -3, 2, +16, 2, -2, -3, 5. Definitely go back and check. Make sure we got signs right in this one. 1, 4, 2, 1, -3, -2, -1, 2, -3. Yeah, and then -1, 16, 5. Okay. So everything's good. And then RREF. So second matrix, go to math, up arrow. It's not faster at that than anything. And then matrix B. Get it to crank it out. So here we see the same idea. We got to roll 1 that's x equals 2. This second column, y equals -2, z equals 1. That's, you guys should have seen this before. It's not anything new. 2, 0, 1, 1, -2, 1, or 0, 0, 1, and then 1. So you get an ordered triple, 2, -2, 1.
So, when you're typing in, do you have to use A&B?
No, you can use any of those matrices. If you wanted, to type in, just do a different one for each problem.
Like, you come with 2 by 3 and
Yeah. Yeah, that's usually what I do. If I look at my work and I know I'm only going to do 2 by 3s, and then I just have a 2 by 3 up there and use it every time. And that way I can just recall my RREF command from the screen. Just press up arrow till I highlight it, hit enter, and it'll do it again. That's helpful. All right. So let's look at example F. We got 2x plus y minus z equals -2, 1, or x, sorry, plus 2y minus z equals -9, x minus 4y plus z equals +1. So throw that into a matrix. And then run RREF on that. See what happens with it. Two, 1, -1, -2, 1, 2, -1, -9, and then 1, -4, 1, 1.
It's like 12.1, you just put in back there and find it, and like 12.3,
Well, no, it's all of it. It's operations will be like 12.2. Some of that row operations. We'll talk about actually doing some row operations by hand and performing some matrix operations before we're done. Performing row operations is another thing that's in these two sections. They kind of like actually 12.1 is solving them by hand. 12.2 is where you start doing the matrix stuff, but I don't see any need in solving it by hand, honestly, because you're going to end up solving them with the calculator anyway. When I beat my head against the wall. All right, so good thing about solving with a matrix is that we can it gives us decimal answers. We can make it convert it to fractions if we want to. Math, enter. Convert those to fractions. But does this one even have answers? No, it's a no solution because the bottom row gets us all zeros and a 1. It doesn't really matter what's up there. That right there tells us that it's no solution. Okay. They have slashes through them. 2s don't. That's why I do that. All right. Look at this one. X minus 2y minus z equals 8. 2x minus 3y plus z equals 23. And then 4x minus 5y plus 5z equals 53. Okay. Let's go to the matrix. Edit. Our 3x4. 1, -2. You guys are obviously faster at typing these in than I am because you can use thumbs. Just click one thing at a time. 4, -5, 5, 53. All right. Make sure I got everything. 1, 2, 4, -2, -3, -5, -1, 1, 5, 8, 23, 53. All right. RREF. There's that command. And I'll get this all zeros in the bottom row. What's that tell us? Infinitely many solutions. So I got 1, 0, 5, 22, 0, 1, 3, 7, and then all zeros. So that's infinitely many solutions. And we'll abbreviate that IMS. What's the other word for infinitely many? Consistent and dependent if it's infinitely many. Independent if it's only one solution. Okay. Now, again, remember, we're going to take this one step further than you did in Algebra 2 or Algebra 1. We're going to write our answers in the form. Let's do in the form of Z. Yeah, you'd have Z, and then everybody else is only got Z's in the variables. Okay. Yeah, you got two equations there to deal with. So you got X plus 5Z equals 22. That one's easy to get X by itself, right? You just subtract 5Z. So X equals -5Z from the matrix. First row of the matrix has X plus 5Z plus 0Y plus 5Z equals 22. So 0Y goes away. So I'm getting this equation from the first row of the matrix. I'm using it to get X in the form of Z. Okay. So X is -5Z plus 22. The second equation has, or second row of the matrix has Y plus 3Z equals 7. That's pretty easy to get Y by itself, right? Subtract 3Z, -3Z plus 7. Mm-hmm. Yeah. Most of the time when you have infinitely many solutions there, the first row is going to have that 1 in the place for the X. So you're going to use it to get the X form. And the second equation usually will have that 1 in the place of where the Y position. And then it'll have the other stuff. You can get the Y equation from there. What you want to do. So not terribly difficult on that one. You get the first row, that's 1x 5z equals 22. That's what that row tells you. And that's how I'm getting this. Yeah, because it's 0 times y, so it just cancels itself out. Yeah, just leave it out. Yeah, leave the zeros out because they're not going to do it. Yeah. So that what that means is if you pick a z value, you could get the x and the y value that's one of the ordered pairs. This is an infinite set of ordered pairs, but they're of this form based on what z is. If z is 2, then you get a certain y value, a certain x value. If z is 5, you get a different x and y value. If z is -18, you get a different x and y value out of that. So it's the form of this, but it's an infinite number of them, but they look a certain way, a certain kind of order triple here. So that's where we take this just a little bit further than you did. We could. Let's do that. It's a little bit more difficult to write it in the form of X and Y because you don't have an equation with like the last row. It's not as easy, but it's doable. So let's do that. It's a good exercise for us. We're going to take this matrix and we're going to write our answers in the form of, let's do X. Okay, so write answers or solutions in the form of X. All right, so that means our order triples are going to look like this. X in the first spot, and we got to find X's in the rest of it. That's a little bit more difficult because you get this equation, X plus 5Z equals 22. Could we solve that for Z? We've solved it for X, but we haven't solved it for Z. So we're going to get Z by itself. So that's doable. Negative X plus 22. Divide everybody by 5. So we get Z is negative 1/5 X plus 22 over 5. That one's not that tough. The next equation, we're trying to get the Y part. We're trying to write this in the form of X. That equation doesn't even have any X's in it. But we do know what Z is in the form of X. We substitute it in. Good. Good. That's exactly what we're going to do. We're going to take this and replace Z with it. 3 parentheses negative 1/5 X 2 over 5 and solve that thing for Y. Or let's see, Y plus negative 3/5 X plus 66 over 5 equals 7. Subtract 66 over 5. It's a good question because you're going to have to do it. And I wasn't planning an example. So they 35 over 5 minus 66 over 5 would be negative 31 over 5. And then add 3/5 X. And there's Y in terms of X. Awesome. Minus 31 over 5. So your X forms are X. The Y portion is 3/5 X minus 31 over 5. And the Z portion is negative 1/5 X plus 22 over 5. Come on. We need the video to work today.